Hi students. So today it is a continuation part for the last session. Okay. So today we have to see the electronic configurations. Already you know that. Okay. Electronic configuration means what? The arrangement of the electrons in the shells. Okay. What is meant by shells? Cells means it's otherwise known as orbit or orbitals. So cells means what? It is the path of the electrons. The orbitals is the path of the electrons. The electrons is revolves around the nucleus with the help of the orbit. Okay, so it is a kind of a stationary circular path. So how we can arrange the electrons in the shells? Because you know that the main shells. Totally we have four important main cells. What are those? K, L, M and N. So these are the main cells which is present in the atoms. So what is the maximum capacity of these cells? So from the last class we can use the formula 2n square. The 2n square is used to calculate the maximum number of electrons which is accommodated to the particular cells. Okay, instead of n you can substitute the number of the particular cells. For example, K means 1 and L means 2 and M means 3 and N means 4. Okay, so instead of n you can substitute those number, you will get the maximum accommodations of the electron in the particular cells. So from using the formula I can get the values. K shell maximum capacity is 2, L shell maximum capacity is 8 and M shell maximum capacity is 18 and nth cell maximum capacity is 32. If you have any doubt means you just see the previous video. Okay, you can easily understand this concept. So the maximum capacity of the K shell is 2 and L cell is 8, M shell is 18 and nth cell is 32. Now we want to write the electronic configuration for some elements. For example, carbon atomic number 6, mass number 12. Okay, for writing the electronic configuration you must know the atomic number, because electronic configuration means the arrangement of the electrons in their shells. So electron number, how can you identify the electron number? You can identify the electron number from the atomic number, because atomic number is equal to number of electron or number of proton. So from the atomic number we know the electron number. Next, totally how many electrons in carbon? 6 electrons. Carbon having 6 electrons. Okay, so next I will arrange the electrons present in the carbon in the respective cells. Okay, so first 2 electrons, I have totally 6 electrons. The first 2 electrons is enter into the K shell. Okay, because K shell is the first shell from the nucleus. Okay, this you consider this is the nucleus, means the first shell is K, second cell is L and the third cell is M and the fourth cell is N. So first cell is K shell, L shell, M shell and the fourth cell is nth cell. Okay, so first we want to fill the K shell. What is the maximum capacity? Means 2. So the first 2 electron is enter into the K shell. So remaining I have how many electrons? First 2 electron is going to the K shell. Remaining I have 4 electrons. That 4 electron is enter into the L shell. Okay, L shell is maximum capacity is 8, but I have only 4 electrons. Totally I have a 6 electron. Out of 6 electrons, the first 2 electrons is enter into the K shell and the remaining electrons is enter into the L shell. So 2, 4. So 2, 4 is the electronic configuration for carbon. The next one is a sodium. Symbol of sodium is Na, because the Latin name of the sodium is natrium. Okay, so that is why the symbol Na is sodium. Okay, so what is the atomic number of sodium? Is 11. So next we want to write the electronic configuration. Same, the first 2 electrons is enter into the K shell. Totally I have 11 electrons. Atomic number is equal to number of electrons. Okay, so totally I have 11 electrons. The first 2 electrons is enter into the K shell. The remaining 8 electron is enter into the L shell. The capacity of L cell is completed. Okay, because totally maximum capacity of L shell is 8, so it is completed. Total number of electrons were filled. How many electrons are filling? Totally 10 electrons were filled. Remaining I have 1 electron. That electron is entered into the mth cell. Okay, so now the electronic configuration of sodium is 2, 8, 1. Able to understand? The first 2 electrons enter into the K shell, the remaining 8 electrons is enter into the L shell. Totally I have filled 10 electrons, remaining I have 1 electron. That electron is enter into the M shell. So 2, 8, 1 is the electronic configuration for sodium atom. So next we will see the another one example. Phosphorus. Okay, atomic number 15. 15 means, what is that? The first 2 electron is enter into the, totally how many electrons it have? Totally 15 electrons it have. Okay, so the first 2 electron is enter into the K shell, the next 8 electron is enter into the L shell. Okay, totally how many electrons are filled? Totally 10 electrons is completed. Remaining I have how many electrons? 5 electron. That 5 electron is enter into that third cell, okay, which means a mth cell. So 2, 8, 5 is the electronic configuration for phosphorus. Okay, you know how to write the electronic configuration? Electronic configuration means nothing but the arrangement of the electrons in the respective cells. Okay, if you know the atomic number, then you can easily arrange the electrons in the respective cells. You must know the maximum capacity of these cells also. Okay, K shell 2 capacity and L cell maximum capacity is 8 electron and M cell maximum capacity is 18 electron and Nth cell maximum capacity is 32 electrons. Okay students, next we have to see the valence electron. Okay, if you can write the electronic configuration easily, means you can easily find out the valence electrons. Okay, what is meant by valence electrons? Before that, valence shell means you know that it is an orbit. Okay, it is a path of electron, you know that. Okay, valence shell means what? The outermost shell from the nucleus, okay, is called as valence shell. The outermost shell, which means the last shell from the nucleus, is considered to be the valence shells. So the number of electron which is present in the valence shell is called as valence electrons. First we want to write some electronic configuration for any element. For example, we consider the nitrogen. Atomic number is 7. Okay, mass number is 14. What is the electronic configuration for nitrogen? The first 2 electrons is enter into the K shell. Remaining, how many electrons I have? 5 electrons. The maximum capacity of the L shell is 8, but I only have the 5 electrons. That 5 electron is enter into the L shell. Totally 7 electron. In 7 electrons, first the 2 electrons enter into the K shell. The remaining electron is enter into the L shell. So 2, 5 is the, what is that? Electronic configuration for nitrogen. So from nitrogen, totally how many cells it have means only 2 shell. One is a K shell and L shell. K shell having 2 electrons and L shell having 5 electrons. So what is the outermost shell? From the nucleus means first shell is K shell, next L shell. You just consider nucleus is here means where is the last shell is there? Which one is the last shell? Whether K or L means L cell is the outermost shell. Okay, so this is called as outermost shell. So the number of electron present in the valence shell is called as valence electron. The valence electron is nothing but the number of electron which is present in the outermost shell is called as valence electron. So here totally valence electron, how many valence electrons have? 5 valence electrons. Let me consider another one examples. For example, fluorine. Okay, atomic number is 9. What is the electronic configuration? 2, 7. So for in this case also, fluorine having 2 cells. One is a K shell and a L shell. Okay, the L shell is the outermost shell, which means a valence shell. So the number of electron present in the valence shell is 7. So the valence electron for fluorine is 7. The next one is sodium. Atomic number 11. So the electronic configuration 2, 8 and 1. Totally 11 electrons. The first 2 electrons enter into the K shell. The remaining 8 electrons enter into the L shell. Remaining I have only 1 electron. That electron is enter into the M shell. Now totally how many cells it have? Totally 3 cells are cells here, K, L and M. So which one is the outermost shell here? The mth cell is the outermost shell, which is called as a valence shell. So the number of electron present in the valence shell is known as valence electron. So how many valence electrons sodium have? It have only 1 valence electron. So the number of valence electron present in sodium is 1. The number of valence electron present in fluorine is 7. And the number of valence electron present in the nitrogen is 5. Be clear? The valence electrons mean what? The number of electrons which is present in the outermost shell or valence shell is called as valence electron. If you know the electronic configuration means you can easily find out the valence electrons. Okay. So next we move on the valency. Valency means what? The valency means it is denoted as it is a combining capacity of the element. The valency is defined as the combining capacity of the element. So how can you find the valency, sir? If you know the valence electron, you can easily calculate the valency of the particular element. Okay, so if you know the atomic number, you can easily write the electronic configuration. If you are writing the electronic configuration, you can easily find out the valence electron. If you know the valence electron, you can easily find the valency. Okay, so valency means it is the combining capacity of the element. The valency is find out from the help of the valence electron. For example, carbon, atomic number 6. The electron distribution or electronic configuration is 2, 4. Oxygen, atomic number 8. So the electronic configuration is 2, 6. The next one is magnesium, atomic number 12. So the electronic distribution 2, 8, 2. Okay. So aluminum, atomic number 13. So the electronic configuration 2, 8, 3. Totally they have 13 electrons. So 2, 8, 3 is the electronic configuration for aluminum. So you know that the valence electrons mean the outermost shell from the nucleus is called as valence shell. So the number of electron present in the valence shell is called as valence electron. So carbon having 4 valence electron, oxygen having 6 valence electron, and magnesium having 2 valence electron, and aluminum having 3 valence electron. Okay, so how can we find the valency, sir? I know the valence electron. How to calculate the valence electron? I know it. How to we find the valency, sir? Means the valency means it is the combining capacity of the element. So it can be find with the help of the valence electron. If the valence electron is 1, 2, 3 and 4 means the valency is also same. Okay, valency, if valence electron 1 means the valency is also 1. If the valence electron 2 means the valency is also 2. If the valency is 3 means the valence electron is 3 means the valency is also 3. Valence electron 4 means the valency is also 4. If the valence electron is equal to 1, 2, 3, 4 means the valency is also same. Okay, but if the valence electron is more than 4, like a 5 or 6 or 7, means you just subtract, okay, those number from 8. So you get 8 minus valence electron, you get the valency. Which means if the valence electron is 5 means what is the valency of the element? Means 8 minus 5, 3. 8 minus 6, 2. 8 minus 7, 1. Okay. So if the valence electron is equal to 1, 2, 3, 4 means the valency is also same. There is no problem. But if the valence electron is more than 4, like a 5, 6, 7 means you just subtract those valence electron from the 8. So 8 minus valence electron, you get the valency. Okay. For example, carbon, valence electron is 4. What about the valency? Valency is also 4. Oxygen, valence electron is 6. Okay, the value is more than 4. So we can subtract this number from 8. So 8 minus 6, 2. So 2 is the valency of the oxygen, which means oxygen can able to combine other 2 element only. The next one is a magnesium. Magnesium valence electron is 2. What about the valency? Valency is also 2. So magnesium is can able to combine with 2 other element. Okay, so aluminium valence electron is 3, valency is also 3, so it can able to combine other 3 element. So valency is the combining capacity of the element. The valency can be find with the help of the valence electron. If the valence electron is 1, 2, 3, 4 means the valency is also same. If the valence electron is more than 4 like a 5, 6, 7 means you just subtract those number from 8. Okay. So okay sir, if the valence electron means 8 means what will we will do sir? For example, neon. Neon is one of the noble gas, atomic number 10. So the electronic configuration is 2,8. What is the valence? How many valence electron present in the neon? 8 valence electron. So what is the combining capacity? What is the valency of neon means? You just subtract from 8. 8 minus 8 which is equal to 0. So neon valency is 0, which means what? Combining capacity is 0, which means which do not combine any other element. Combining capacity is 0 means it do not combine any other element. So neon is belongs to the noble gas or inert gas. It doesn't combine with any other element. It is always present in the individual element. Okay, so combining capacity, the valency is nothing but it is the combining capacity of the element. If you know to write the electronic configuration, then easily you can find the valency of the element. So the next one is the geometrical representations. 8, 16. Okay, from the atomic number you must know the value of a electron, number of electron. You can easily find the number of electron and a proton. How many electrons it have? Totally 8 electrons. Proton, 8 protons. What about the neutron? So neutron detect பண்றதுக்கு formula A minus Z. Okay. By using this formula we can find the number of neutron present in the element. A means mass number, Z means atomic number. So mass number minus atomic number. Mass number 16 for oxygen minus 8. So remaining 8. So the number of neutron is also present in the oxygen is 8. Okay. So where the proton and the neutrons are collectively known as nucleons, which is present in the nucleus, which means totally 8 protons, okay, and 8 neutrons. The remaining electron is there, where the electron is revolves around the nucleus in a stationary circular path, that is called as orbit. The electrons are present in the orbit. Okay, next we want to write the electronic configuration. Totally I have 8 electrons. Okay, what is the electronic configuration for oxygen? 2,6. Okay, totally I have 8 electrons. The first 2 electrons is enter into the K shell. Remaining I have a 6 electron. That electron is enter into the L shell. So the electronic configuration for oxygen is 2,6. Okay, so first shell is K shell. Second shell is L shell. In K shells I have 2 electrons. Okay, and L shells I have a 6 electrons. 1, 2, 3, 4, 5 and 6. So this is the geometrical representation for oxygen atom. Okay, likewise in your book they given the 20 examples. Okay, you just practice it. If you have any doubt means you just clarify by phone call or otherwise any messages. Okay, thank you students.